2. This one I'm going to do question number 3. The reason I'm doing that is because I want to use a calculator for this. So here it's the cooling of a cup of hot chocolate, and you're given the equation where capital T is the temperature and X is time in minutes. And in A it says sketch graph. Now you can do that by selecting values of X between 0 and 12, finding out what the Y value is, or the temperature, and then plotting those. That could take a little while, so I'll try to show you something a little faster on the calculator. So here, if you go to your menu, I've already cheated here a bit, go to graph. It looks a little different than yours, but it's essentially the same kind of calculator. Type in the equation, as I did here, and then you're good to go. But if you draw, if you draw, you might end up with something like this, which is absolutely nothing. So you have to go to your window, your V window there. So I'm going to go V window, like that. And think about what your X values, minimum, maximum, and your Y values, minimum, maximum are. So in this question, it tells you to go from 0 to 12 minutes. That's your X value. So 0. And then maximum 12, you could go a little higher if you want to kind of see kind of the bigger picture. Scale doesn't matter. And I wasn't finished, so I wasn't paying attention to what I was typing. So I'm going to go back to V window, and I want to keep going down here. Now my Y minimum, what's my minimum temperature? What's my maximum temperature? Well, if you have no idea, I assume you can at least figure out that if it's a cooling cup of hot chocolate, you go 0 would be your minimum temperature, otherwise it's an ice cube, and maximum is 100 because that would be a boiling cup of hot chocolate and wouldn't exceed that. But you can look at the equation a little bit and gain a little bit more information. So first of all, if the X has a negative in front of it, it is a decreasing function, which means it has this kind of curve. Sorry, I don't have so it's decreasing like that. It's just flattening out as X gets larger and larger and larger. So this thing is cooling. So if you let X to be a very large value, you'll find out what this thing is going towards. Now I can tell you that if this is negative, and that's a very large value, you're making this equal to something closer and closer to 0. So it'd be 70 times 0 plus 21. It'll be in the bottom line. 21 will be your minimum temperature. I'll make it a little lower. I'll make it 20 or something like that. And then for the next one, maximum temperature. Again, 100 is boiling. Makes a lot of sense. But if you really insist, you're starting off because the thing is cooling at the highest temperature. So if you let X equal to 0, you will quickly find out that 1.45 raised to the power of 0 is 1. 70 times 1 is 70, plus 21 is 91. You can do that on your calculator. So 91. In fact, though, I might just go for that 100. So I'm going to clear that and go with 100. There we go. And I'm pretty satisfied with that. I think I will get a graph out of that. Okay, so let's draw that. There you go. That's what it looks like. Very nice. I can trace it if I want and see what some of the values are. So as I change X, I get different temperatures. So I get different values for Y. That can help you in graphing it. Another thing that can help you in graphing it is if you go to the menu here, there should be something like a table. I'm not sure if this table will be exactly what I want, but yours is definitely on your calculator. It's definitely table. And yes, and you will get something like this where instead of draw here, you'll see table. You'll also see set. So I'm going to set this. Take a look at this. You're going to be able to do this. What do you want your X value to start off at? I'm going to start at 0. And I'm going to go all the way to 12 because it's from 0 to 12 minutes here. And step 1, which means 0, and then the 1, 2, 3, 4, 5. If you wanted decimals, you can put in like 0.1 or something like that. So I'm good here, so I'm going to exit, and then I'm going to draw that table. No item selected. So I got to make sure that that's on select. I think that's a little different than your calculator. So there you go. You'll end up with something like that. So when x is 0, the y is 91. When it's 1, 2, so you get a nice little table of values, nice clean values here. Notice you're getting closer and closer. It's not changing very much here, and you're slowly getting closer and closer to 21. If you kept going, which you can't because I set the maximum to be 12, you would get that. So that should really help you for sketching it, which is the tough part here. So find the initial temperature. Okay, the same thing as before. As the first example, that's when x equals 0, so it's 91 degrees Celsius. Find the temperature after 5 minutes. Look how nice it is with this table. It's 31.92 degrees Celsius. Find the number of minutes it takes for the hot chocolate to reach 50. Well, I can't tell exactly here, but it looks like it's between minute number 2 and 3, right? Take a look at that. And again, with your calculator, if you get good at this, I can exit out of here. Let's go back to the graph. I can do something with that, so I can draw it. And then I can G-solve it. Remember that? So I can solve that value. So what was it again? I wanted the calculate, what do I want? The number of minutes it takes for the hot chocolate to reach 50 degrees. So I think I want x calculate, is that right? That's right. So 50 degrees. So it'll happen at 2.37 minutes. That's not 2 minutes and 37 seconds. It's 2 minutes and 37 over 100 times 60 seconds. It's what fraction of 60 seconds? So again, it's 2 minutes and 37 divided by 100 times 60. That'll give you the number of seconds. Write that down. Think long and hard about that. Okay? Or another way to think about it, 2 minutes and 0.37 times 60, which will give you the number of seconds. In fact, let's calculate that. So that's 2 minutes and what's 0.37 times 60? It's 22 seconds. So 2 minutes and 22 seconds. So there you go. What else do they want to find out here? What about E? Write down the equation of the horizontal asymptote of the graph. So the horizontal asymptote, what's the lowest that this thing's go? What line, horizontal line, will it not cross, but get really close to? It's when x gets very, very large, you get very, very close to, just make that x in that equation here very large. Put it in your calculator if you want. You'll find out that it's 21. But this is always your asymptote, the plus whatever. If there's plus nothing, it's 0. So y, or t in this case, equals 21 is your equation. Or if you want, y equals 21. And F, write down the temperature of the room. Well, it's the same thing. What happens when something cools? It gets closer and closer to the room temperature. There you go. End of that lesson.